Okay, guys, in this example, we're going to look at a data set, hours of study, and the grade. And let's go ahead and answer some of these questions. So the first thing I'll do is just open this in Desmos. And let's copy paste the data into Desmos first. Then we are going to fit the regression line by clicking on the little button there. And it asks us correlation. So correlation is the value of R right here. So this is correlation. Okay, that's the correlation coefficient. So that's equal to 0.9065. And according to our scale, if we look at the scale, the correlation is definitely positive. So we do have a positive relationship, and it is between zero point 0.7 and 1. So it's a strong positive relationship. So let's select that. Okay, next we need to type up the equation here, and it wants the coefficients rounded to 3 decimal places. So to do that, we're going to export a snapshot, okay, of the equation. And we want 3 decimal places for the slope and for the intercept. So let's select the slope first. 3 decimals. So let's type that here next to x plus. And then we also want to select the y-intercept and round that to 3 decimal places. So that's 69,286. Okay, so hopefully that's correct. Now, whenever you want to interpret the slope and the intercept, what do you do? Okay, so let me just put this side by side so I can write down the interpretation. So for the slope, you're going to say if, then you're going to have a blank, increases by 1, then another blank is predicted to either increase or decrease. So we'll say increase or decrease. And in a second, we're going to decide what. By, and then here you should put absolute value of the slope. So what do we put in the first blank? So we put the x variable, and in the second blank we will put the y variable. But what's x and what's y? When you go back over here, you can see the column heading. So the column heading is hours of study. You can also see that on over here, and then the grade is y. So instead of x, you're gonna say number of hours. And here you're gonna say grade. Now, to decide whether it's going to be increase or decrease, you can see the correlation or the slope. They always have the same sign. So both the correlation and the slope, 4.4, they're both positive. So this is going to say increase, and then this should be 4.4 here. Okay, so it will say if a student studies 1 extra hour, the grade is predicted to increase by 4.4. So that would be the correct answer. Okay, now in terms of the y-intercept, here's how that looks like. If blank is 0, then blank is predicted to be, so predicted to be, and then another blank. Okay, so what goes where? So first blank is the x. So if the number of hours is 0, in other words, student did not study, then the grade is predicted to be like, well, let's take a look what the y-intercept was, 69.3. So if a student didn't study, then his or her grade is predicted to be 69.3. Now, sometimes, as you can see, the interpretation is not appropriate. And to figure out if it is or it isn't, you have to look at your x range. So look at these values, and if you see a 0, and I do see a 0 right here, then you should go ahead and interpret. Okay, the last part we need to do is actually do the predictions. So how do we do that? Well, we need our equation. Okay, so let me get rid of this. So here it says, predict the grade of a student who studied 5 hours. So instead of x, we're going to put in parentheses 5. And it's going to give me 91.4. So that would be a grade of a student. Now here it says predict the grade of a student who studied 9 hours. And you may be tempted to just put 9 and say, okay, the grade is 109. But this prediction is not appropriate. Why? Because when you look at the range of your x values, they do not include anything other than from 0 to 6. So if the values are in that range, you can go ahead and predict, otherwise you don't. So 9 is definitely not between 0 and 6. So here you just type D and E.